Hello friends, welcome to Shiksharthi. In this video, we will be discussing similarity along with basic proportionality theorem. So let's start. Now, here the focus in this video will be on two-dimensional geometry. So when we are talking about two-dimensional geometry, any figure that we draw, any figure, for example, if I have drawn this triangle, so any figure that we are drawing will be focusing on few points, and those few points are, we'll be talking about vertices or vertices, we'll be talking about sides, and thereafter we'll be talking about angles. And last but not the least, we'll be talking about, when we are talking about the sides, we will mention the number of sides, and at the same time we will talk about the length of the sides. So here sides will get divided into two parts, wherein one we are talking about the number of sides and the next we are talking about the length of the sides. Vertices, we will talk about the number of vertices, and thereafter finally we'll be talking about the angles. Now when we talk about angles, then you can further segment them as, are all the three angles equal, or one of them is equal, one of them is unequal, whatever. Okay, so here in this video we are going to talk about similarity in triangles, right? So let us start off with two statements. So for example, if I say in a triangle equal sides subtend equal angles, or equal angles make equal sides or subtend equal sides. Now the question here is, these two statements, among these two or between these two statements, what are the kind of answers that you can give here? Because this is, we are talking about the basics. So before we start off, we need to understand the basics when you are talking about similarity or when we talk about congruency. But in this video, the focus will be on similarity only. Okay. So now when we say equal sides, and if we consider a triangle like this, we are saying what? Equal sides subtend equal angles. So what are we basically talking about? So if I say, so based on this statement, let us talk about types of triangles. So the first kind of a triangle that you can talk about is let's say a scalene triangle where none of the sides are equal. So you will see that this statement becomes meaningless when we talk about scalene triangle, but this statement becomes very meaningful when we talk about isosceles and when we talk about equilateral triangles. So let us try and understand when we are talking about, let's say, an isosceles triangle. So let's take an isosceles triangle as PQR. So we know that in an isosceles triangle, the length of any two sides, now when I say length of any two sides, we can choose PQ along with QR, or we can choose PQ along with PR, or we can choose QR along with what is left. So we can select QR with PR. So these are the three selections that you can do. So implicitly you will see reasoning, when you get into reasoning or when you're trying to find out the reason behind why does this happen. So any kind of a reasoning will always include some element or a major element of permutations and combinations, right? So when we are saying that there is an isosceles triangle that has been formed, we know that any two sides of an isosceles triangle are equal. And the moment we say this, thereafter we say that because of these two sides being equal, for example, if we take these two sides being equal, so these two sides, so this side subtends an angle, let's say A, and this side will also subtend an angle A. So can we say that equal sides in a triangle, equal sides subtend equal angles? Yes, this statement is absolutely correct. Vis-a-vis, if I say that in an isosceles triangle, two interior angles, any two interior angles are equal. So now when we are saying any two interior angles being equal, we are basically referring to what? Let us choose these. The first. So either we are saying angle P is equal to angle Q, or we are saying angle P is equal to angle R, or we are saying angle Q is equal to angle R. So in an isosceles triangle, in a triangle, we can always start off the discussion either by talking of angles, or by talking of sides, or by talking about both of them. Which is just like we are selecting only angles, or we are selecting only sides, or we are selecting a combination of both of them. So coming back, so I could have also started off with, in an isosceles triangle, if any two interior angles of a triangle are equal, that means it is an isosceles triangle. And if any two angles are equal, let us say that we say that angle Q is equal to angle R, in that case equal angles make equal sides. So that means we are talking about the sides opposite to the angles is what we are talking about. So is the second statement correct? Yes, it is. And when it is true for isosceles triangles, it will be true for equilateral triangles as well, because in an equilateral triangle all the three sides are equal, and thereafter you can say all the three interior angles subtended by the three equal sides are equal, and each angle becomes equal to 60 degrees is the definition of an equilateral triangle. Similarly, we could have started off this definition from the angle itself. So if we say that if all the three interior angles of a triangle are equal, henceforth the triangle that is formed will have all the three sides as equal. So when we are talking about all the three sides being equal, we are talking about the length of the sides being equal. I hope this part is clear. So this is in geometry, when you are talking about 2D geometry, we will basically be, and when we are talking about triangles, it goes without saying, these two statements are very, very important. Now coming down to what I was discussing few minutes back. So when you're talking about a triangle, you will talk about vertices or sides or angles, and thereafter what we discussed. So either we are talking about angles only, which is just like saying a triangle S plus A. S is for the sides, the number of sides, and A is for the number of angles. The number of angles is what we are referring to. Now sides plus angles should be equal to 3. Why are we talking about this? In few minutes you will understand this. So either we talk about angles only. So when we are talking about angles only, what are we referring to? So this means we are talking about one angle, another angle, followed by the third angle. Angle, angle, angle. Now keeping in mind that all the three angles may be unequal, which is why you will get a scalene triangle, because unequal angles. So when we say equal angles subtend equal sides, at the same time the negative of it. What is the negative statement here? Unequal angles will subtend unequal angles. Unequal angles will make unequal sides. Something of that sort is what you can say. Or the sides opposite to unequal angles will be unequal. Okay. Now, so this is the first case when we are talking about angles only. So when we are talking about angles only, is this case? This is the case that we get. When we are talking about sides only, so we are not talking about angles. So the count of angles is 0, but the count of number of sides in the triangle is 3. So this is just like saying S, S, S. Thereafter, now we can talk about a combination of some sides and some angles. But when we are talking about the combination of sides and angles, please remember that the total count cannot exceed 3. Okay. So this is just like saying one side along with two angles. So one side along with two angles, and then their various arrangements. What could be a various arrangement? Another arrangement here could be AAS, and the third arrangement here could be what? ASA. Next case, when we are talking about exactly two sides and we are talking about one angle. Now when we are talking about exactly two sides and then we are talking about one angle, so when we are talking about exactly two sides, so these exactly two sides may be in succession, may not be in succession. So when we talk about this side and this side, when we talk about this side and this side, when we talk about this side and this side. So in any case in the triangle, any two sides when considered will always be in succession only. Why? Because a triangle is formed of three non-collinear points. Okay. Okay, so coming back here, so when we are talking about 2s, so double SA, what are other permutations that I can have, arrangements for double SA? One is I can have SAS, and the last that I can have here is ASS. Incidentally, now all these outcomes that we have had is just like saying what? 1, 2, 3, 4, 5, 6, 7, 8. Now these 8 outcomes would act like tests for similarity and congruency both, or some of these tests would be for similarity only, some of them would be for congruency only, and some of them would be common to both similarity and congruency. But before we do that, let us understand what is the definition of similarity. I mean, what do you mean by if two people are similar? What will you say? If I say there are two people, they appear to be similar, you will say similarity is basically about appearance. And in 2D geometry, when we talk about appearance, it basically refers to shape. And when we talk about shape, shape basically refers to angles. So similarity is all about shape, and shape is all about angles. So when you're talking about tests for similarity, what could be the possible tests for similarity? Please mark the words being used. I am basically talking about what could be the possible tests for similarity. Should it be only A, or it could be a combination of A and S? Why do I say this? Because few minutes back we talked about these two statements, which is why I said that these two statements are utterly important. Okay, so this is a test, a triple A or a double A test, because in the triangle, if two interior angles are equal, naturally the third angle would be the same. Second question which arises before we talk about similarity. Now when you're talking about similarity, how many entities do you require? I mean, you will never talk about a single triangle being similar. Similar to what? So similarity requires at least two things to be chosen. So now when you're talking about similarity of triangles or similarity in triangles, you have to basically talk about at least two triangles at a time. So when we are talking about at least two triangles at a time is when similarity comes into picture. Similarity or congruency, both. Thereafter we talk about, okay, out of these 8 reasonings, which reasoning could act as an acid test for similarity? I mean, which could act as a test? So one test is AAA. Another test here is triple S. Now why do I say this? We have the answer from here only. And the third test here is SAS. There is no other test that you can use for similarity. So you will see that there are some tests which become redundant. Now when I use the word redundant, you need to understand that when we are saying that one side of a triangle is equal to another side of the triangle, and thereafter we are talking about any two angles being equal. So this becomes very ambiguous, and a test should always be unambiguous. Unambiguous means it should be it should have a unique interpretation, which is why this will never act as a test for similarity. Now when we are talking about double AS may not act as a test for similarity but may act as a test for congruency. When we are talking about ASA, this may not act as a test for similarity but for congruency. SSA, we have to see that this becomes redundant, and at the same time this is as work, this becomes redundant. So out of 8 tests, you would see there are 5 tests which are very meaningful. Now what you need to do is you need to identify why are these meaningful based on the discussions that we have had till now under the head of 2D geometry, and that too similarity of or in triangles. Right? Taking this discussion forward. Now we have understood and we know now that there are 3 tests that we can use for similarity. So what are those 3 tests? Either I use AA or AAA, or I use triple S, or I use SAS. Now the next question which arises here is how to use this SAS. So when you're talking about SAS, you're talking about this side, then a common angle followed by the third side. Or you talk about this side, the common angle and the third side, or you're talking about this side, the common angle and the third side, the second side. This is how we use SAS. Okay, so now coming down to the discussion of similarity, and we know that AA or AAA is a test for similarity. So now if I have to prove that these two triangles are similar, what do I need to, the information that I need to have here is, if any two angles of two different triangles are equal, if any two angles of two triangles are equal, naturally the third angle of both the triangle also becomes equal. In that case, we will say that both the triangles are similar. Right? Now, the moment we say any two angles being equal, so any two angles being equal, naturally the third angle becomes equal. Thereafter, you will be able to say that the ratio of their sides. So, you will be able to take the ratio of their sides. So you will say if these two angles are equal, these two sides would be equal. If these two angles are equal, AC becomes equal to PR. If angle A is equal to angle P, then you are saying the opposite sides, which is BC becomes equal to QR. Can we say this? Now the point here is, can we say this? No, we can't. Because we talked about, otherwise the entire discussion of similarity and congruency evaporates. I'll repeat what I said. If somebody tells me that these are two different triangles, and the triangles that we have considered here are triangle ABC and triangle PQR, such that exactly two angles of these both triangles are equal. So let us assume that angle A is equal to angle P was already given to you, and angle B is equal to angle Q was already given to you. So naturally you will be able to say that the third angle, angle C, will be equal to angle R. Based on this piece of information, can I say that BC becomes equal to QR, which is just like saying equal angle subtends equal sides? No, we can't say this, because what we discussed, this was true only for one triangle. This was not true for two triangles. So this discussion is totally incorrect. Please don't commit this mistake. The only thing that we can say after this is, we can say that triangle ABC is similar to, this is the sign that we use for similarity, is similar to triangle PQR. This is the only thing we can say after this. Moving forward, now if somebody tells me that there are two triangles which are similar. So one triangle that I am considering here is, let us say I have taken one triangle as ABC, and the next triangle that I have taken here is a triangle inside a triangle. And somebody tells me that these triangles are similar. Okay. So if triangle ABC is similar to triangle APQ, then I can have various combinations of the vertices here. And how many triangles can be formed with the help of vertices APQ? You can form 6 different triangles with the vertices, with 3 different vertices. With 3 different vertices, you can form 6 different triangles, and you can just apply the concept of permutations and arrangements here. Now, if I say that there are two triangles which are equal, so naturally from here, this is just like saying angle A is equal to angle A. At the same time, we are saying angle B is equal to angle P, and angle C is equal to angle Q. From here is what we are saying. This is the byproduct of similarity. If I say this, then I would have been able to say this. So if somebody tells me that these are two angles which are equal, what kind of triangles does this piece of information indicate? It indicates that these two triangles, there are 3 different vertices. Here the 3 different vertices for one triangle is ABC, and the 3 different vertices for another triangle here are APQ. So I'll be able to say triangle ABC will be similar to triangle APQ, is all I can say. The next thing that I can say here is, maybe both the triangles are mutually exclusive to each other. They don't intersect with each other. At the same time, I can say that there can be a possibility that triangle inside a triangle can be similar. So I have taken that example. Right? Okay. So now if this holds good, will this hold good? Let's check. So based on this, now if I say triangle ABC is similar to triangle APQ, this is the byproduct of that. So can I say triangle ABC will be similar to triangle AQP? No, it contradicts this. Same for others. So please remember, in similarity, the order of the vertices is very important. I repeat, in similarity, when you talk about similarity of two triangles, the order of the vertices is very, very important. Please remember this. Last but not the least, whatever we have discussed in terms of similarity and the tests that we are supposed to use for similarity, let us talk about basic proportionality theorem. And basic proportionality theorem is nothing but the outcome of AAA or AA. Let's see how. So what I have done here is, I have taken one triangle as APQ, and inside this triangle I have taken another triangle ABC, such that, now what is the given piece of information here? BC is parallel to PQ. This is already given. Now why did I take this? Now the moment I say BC is parallel to PQ, now I know angle A becomes equal to angle A, which is already given because one of the vertex is common to both the triangles. Okay. Now I wanted that the remaining two angles should have been equal. So when I'm placing one triangle inside another triangle and I want exactly two angles to be equal, what will I do? One angle becomes equal and I'm now looking for one more angle to be equal. Now one more angle can be made easily equal with the help of a minor change, and the minor change is I can draw two lines parallel to each other. Now when I draw two lines parallel to each other, which is just like saying BC is parallel to PQ, I'll be able to say that angle B is equal to angle P. And which type of angles are these? These are corresponding angles or alternate angles? Corresponding angles is what we are talking about. And consequent to this, you will be able to say that angle C becomes equal to angle Q. Right? And then thereafter you can prove certain things. So in next few minutes, we will talk about what have we proved exactly. Okay. So now if I'm using AR, I'm basically the area, I'm using a subscript along with A. Again, I'm talking about area only. So you will see when we are talking about this, we have drawn two parallel lines and I have drawn another set of perpendicular lines, and I have drawn the perpendicular from C to E and another perpendicular from B to D. So in geometry, if you see, I had already written here, please focus on two P's. Now, which are the two P's that I am talking about? In geometry, if you have to prove anything or you have to come down to a logical conclusion or you are stuck up anywhere and you cannot see any other way, follow the concept of 2P. One P is parallel and the other P here is perpendicular. Follow this concept. This is going to help you immensely, and this will help you only when you can help yourself. Right? So we are using the concept of two P's here only. We have drawn two lines parallel to each other and at the same time we have drawn two lines perpendicular to each other. What is your objective? The objective is to prove BPT theorem. And what is BPT theorem? If I draw one triangle inside another triangle, or if I draw one triangle outside another triangle, but I am able to say that these two triangles, so whether these two triangles or these two triangles here refers to, I'm talking about triangle ABC and APQ, are similar to each other. So when there are two triangles similar to each other, then as a byproduct you can prove basic proportionality theorem. And what is basic proportionality theorem? Follow the same order. The order here is, if triangle ABC is similar to triangle PQR, I'll say AB divided by PQ. Follow the order, because few minutes back we talked about in similarity the order of the vertices is very important. So you are supposed to choose any two vertices. Choosing any two vertices, the line that joins any two vertices becomes a line segment. Okay, so now the line segment AB divided by the line segment PQ becomes equal to the line segment AC divided by the line segment analogously PR becomes equal to the line segment BC divided by the line segment QR. Now this you are getting basic proportionality. So this is proportion. Now this answer may be equal to a 1 or this answer may not be equal to a 1. So when this answer, I mean the ratio that you are taking or the fractions that you are taking, all the fractions they don't accumulate into being equal to 1. It is then only that we talk about similarity. What happens when it becomes equal to a 1? In that case, we will not talk about similarity. So when we are not talking about similarity, we will talk about what? We will talk about congruency. Right? So similarly, we will do the same thing here. So if we are saying that triangle ABC is similar to triangle APQ, which they are, so can we say that AB, which is this side divided by the entire side, which is AP, is equal to AC divided by the entire side, which is AQ, which is equal to BC divided by the entire side, PQ. This is what I have explained here. So, which is just like saying, just to give you a pre-thought, because the rest you are supposed to do it yourself. So just to give you a pre-thought here, if I say now these two sides are parallel to each other, can I say that the area of this triangle, which triangle? The area of the triangle BCQ is the same as the area of the triangle BCQ is the same as the area of the triangle BCP or BPC. I repeat, the area of the triangle BCQ is the same as the area of the triangle BCP or BPC. Which property am I using? So these two triangles have the same base, which is BC, and they have the same height. Why do they have the same height? Because between two parallel sides, the perpendicular distance remains the same. So you will have a common height. So this is what I have used. So I made one equation. Another, we know that inside this triangle, the area can be written like area of triangle ABC is equal to triangle ABC. Now triangle ABC, one side I can say this is half into this base into height, and the other side I can say this is half into this base into height. So from here I got another equation. I combined both the equations and I was able to establish the BPT theorem. Please remember, in triangles, similarity and congruency and the concept of two P's and these two statements that we have discussed, plus the tests, are very, very important, not only for 2D, but for 3D geometry also, and at the same time for 2D circles and 3D circles as well, 3D figures as well. It is very, very important. Hope you understood what we discussed today. So please take it to the next level. If you feel that something very knowledgeable and something very, very different has been discussed today, give a thumbs up mark for the video. Okay. At the same time, if you have already subscribed to this channel, please click on the bell icon and select all so that you can start receiving updates from us regularly. Thank you so much. Until next we meet. Goodbye.